Hello, my name is Rob Reynolds. Welcome to College Algebra. This is section 3.2. Before we talk about graphs of functions, I wanted to back up and talk to you about section 3.1 when we talked about what makes a function. And a relation is a set of ordered pairs, but a function is that defined so that every x value has only one y value. So this is not a function because Colleen has two phone numbers. It goes to two, so that's not a function. This is called a one-to-one function because for every x there's only one y, and that means the vertical line test and the horizontal line test passes. So we were talking about what makes a function and what does not make a function from section 3.1. We also looked at a very important definition, f of x plus h minus f of x all divided by h. This is a calculus definition that you will use for limits, and there was another practice problem that I would recommend that you work through and see if you can understand the concepts here. Before I begin section 3.2, I'll finish this up. I would do f of x plus h first. So f of x plus h says every time you see an x, replace it with parentheses, was the rule that I gave on section 3.1. So instead of writing x's here, I'm going to write parentheses. And then inside the parentheses, I will fill in what value I'm doing. So the value is x plus h. So I'm plugging in x plus h for x. I'm not going to distribute. That would be a mistake, but I will FOIL this out to get x squared plus 2xh plus h squared minus 2x minus 2h plus 6. Now remember, all of that is just, well, I'll do one more statement here. 3x squared plus 6xh plus h squared minus 2x minus 2h plus 6. All of that is your f of x plus h. Now I need to subtract off the function. And then lastly, I'll divide by h. So to subtract off the function, here is the function. I'm just going to distribute the negative throughout. So it's negative 3x squared. I'm subtracting every term. So it's a positive 2x, and this positive 6 goes to a negative x. Because remember, I'm doing the opposite of the function. Once you have subtracted off the function, some things will start canceling here. The negative 6 and the positive 6, the 2x and the negative 2x, and the negative 3x squared and the 3x squared, leaving me with some h terms. And I think I can factor out an h from the three remaining terms that are left, leaving me 6x plus h minus 2, all divided by h. The h terms will cancel, and I'm left with, in this example, 6x plus h minus 2. Again, that concept's not going away. Practice that. So also in section 3.1, we started looking at implicit and explicit. And implicit means that it's not solved for y, and explicit form means it's solved for y, and it's easier to find the domain in the explicit form. So we're talking about the domain. Remember, you can't divide by 0, so factor this and find out what would cause that to be 0. And then section 3.1 discussed don't have negatives underneath the radicals. What I didn't get to in section 3.1 is this story problem, which is kind of an important concept as well. So I wanted to back up before I start section 3.2. It says a rectangular garden has a perimeter, and we know the definition of a perimeter is twice the length plus twice the width. And it says that the perimeter is 100 feet. So I'm going to plug in 100 feet here for the perimeter. So I know twice the length plus twice the width is the perimeter. So instead of doing L plus W, I'll say the perimeter is 2 L's plus 2 W's. It also tells me that the area formula, which we know is length times width, can be expressed in terms of width. So I want to get rid of my L here. So I'm going to solve. I want to get rid of this L, and I want to solve for the area in terms of W. So to solve for L, I'm going to try to solve for this L. So twice the L is 100 minus 2W. I'll divide everything through by 2 to get 50 minus W is equal to L. And I'm going to take that 50 minus W and plug that in here. So W times the 50 minus W will give me the area of the rectangle in terms of the W. So 50W minus W squared. And you can see that's worked out right here. Same solution, I just left it in factored form. So that finishes up, and then to talk about the domain of this thing, you would say that the width can be no more than 0, because if the width was, you can't have negative width. And then this factor tells you that you can't have a width anything greater than 50. So that is the end of section 3.1. So this is just notation that you can add functions. This is notation for subtracting functions, multiplying functions, and dividing functions. Just some notation here, and then some practice form. So that's the end of section 3.1. Let's start section 3.2. So section 3.2 starts talking about the graphs of the functions. So we start looking at some t-charts. We look at the lines. They're decreasing and then increasing, just plotting some points. But we're going to move on to this vertical line test. For every x, there's only one y. So if the vertical line test passes, that means it's a function. In this case, this s is not a function, because for every x, there's not just one y. In this case, if the x value was 3, you can see maybe this point is 3, 7, and then this point would be like 3, 4, and this point would be 3, 1, and that's not a function. For every x, there's not just one y. But over here, this does pass the vertical line test, because no matter where I draw that vertical line, I could even slide that vertical line along, and anywhere I draw these vertical lines, it's going to pass the function. So again, this is a function. It only crosses once. This is a function. We know this is a parabola. This is a cubic function. Those are great functions. This is not a function. This is your x equals y squared. Remember, if you were to square root both sides, we'll get y is equal to plus or minus the square root of x. And that's not just one y. Remember, for every x, there can only be one y. And again, same thing over here. If you were to solve for y, you wouldn't have just one y. You would have two y's, because you're going to take the square root of this and you're going to get a plus or minus again. And that cannot happen. So a circle, not a function. It's a relation, but not a function. So we're talking about the vertical line test. This is a good problem because it kind of brings to the forefront some good definitions. This stands for what's the y value if x is 0. So remember, f of x is asking for y. So I'm saying at 0, what's the y value? So I'm going to look here and say if you let x be 0, which is right here, the y value is 4. And here, if the x value is 3 pi over 2, you have a 0. And at 3 pi, if you let the x value be 3 pi, you get the negative 4. This is saying what's the domain? Remember, your domains go from left to right. So moving from left to right, the domain are just the x values. The x values from left to right. So domains are your x's and your ranges are your y's, and they're going to go bottom to top. So the domain, starting with the first x value, we start at 0, and I think we end at 4 pi. So the domain is between 0 and 4 pi, including 0, including 4 pi. And the range would be bottom to top. So here's the bottom and here's the top. So the bottom, remember, it's the y value. It goes from negative 4, that's the lowest that it goes, down to negative 4, and it goes all the way up to 4. So I would say between negative 4 and 4 for the range. Listing the intercepts, I have several intercepts here. I have 1, 2, 3, 4 intercepts, and then 1 y-intercept. So I would list all of those points as ordered pairs. So list all 5. There's 4 x-intercepts, and then a 5th y-intercept. How often does the line y equals 2 intersect? Well, I'll graph it here, and it looks like the line y equals 2 intersects it once, twice, 3 times, 4 times. So I would say this intersects 4 times. For what values does x, the y value equals 4 is how I'm going to read that. So here's a y value of 4 and here's a y value of 4. So I'm going to pick off pi and 3 pi for those two answers. And down here it says for what values of x is the y value greater than 0. And the y value is greater than 0 for everything that's above this yellow line. So I'll try to graph in this piece, it's greater than 0, this piece is greater than 0, and this piece is greater than 0. So for those answers, I would say, okay, let's go interval notation. Between 0 and the x value, pi over 2, that interval, it's greater than 0. It's not equal to it, so I can't use brackets. Then I'm going to start here at the x value 3 pi over 2 and go to 5 pi over 2. So between 3 pi over 2 and 5 pi over 2, we have an interval that's greater than. And then the last interval that's greater, starting here at 7 pi over 2 and going up to 4 pi. So those are my intervals that the function is above the yellow line. That's a good problem. I hope that's helpful. Here's all the solutions. You can pause the video and read this. All right, so for this one it says, consider the function. I can see I've got a domain restriction down here because I don't want to let x be -1 because that would cause me to divide by 0. So it says, is the point 1 1/2 on the graph? So if I let x be 1, I'm going to check, does y equal 1/2? So I'm really asking, does f of 1 equal 1/2? And we can check it really quick. Let's see, 1 over 1 plus 1 is certainly 1/2, so I would say yes, it does. For part B, if x is 2, what's the y value? So well, let's go ahead and let x be 2. So 2 over 2 plus 1, looks like the y value would be 2/3. What point is on the graph? And the x value is 2, so the point would be 2 comma 2/3 is the point that's on the graph. This one says if you let y equal 2, find me the x. So if you say 2 is equal to x over x plus 1, we're going to try to solve this for x. So the first thing I'm going to look for is multiplying both sides by the common denominator, and then I'll distribute this. So 2x plus 2 is equal to x. I'll subtract off x, subtract off a 2, and it looks like if x is -2, then y needs to be a 2. That's the point on the graph. So again, here are some solutions. I hope I did that right. Well, this actually looks like a different problem because their function is x plus 1 divided by x plus 2, and the function that I worked out was just x over x plus 1. So this is not actually solutions to the previous slide, but these are good examples too of a different problem. This problem is talking about the average cost, and it's saying you could plug in, you could let x be 30, you could let x be 40, let x be 50, and try to solve for the cost. I would recommend you doing this on your graphing calculator. It gets a little bit tricky to kind of set your window, but there's a hint of what to set your window range, and I'll walk you through that together. So for this problem, the first thing I'm going to look at is going to my y equals here, and every time I want to type in an x value, I'll use this key for x. I've typed in the problem, and here's my x squared key here. So I'm going to try to hit zoom 6. This will give me a standard 10 by 10 by 10 graph, and I'm not really surprised when I don't find anything because oftentimes the function won't fit in a 10 by 10 graph. So I'm going to hit zoom 0, which is a zoom fit function, and what it's trying to do is fit the function, or at least find the function. It looks like I found something. I'll go to my window, and I can see that the x max is only 10 though, and in order to trace 30 computers, I'll need to change this at least out to 50. In fact, let's go out to maybe even 80, because it looks like they're asking us in this problem here to go between 0, let x be between 0 and 80. So on my graphing calculator, I really probably, if I want to follow what their recommendation is, let the x be 0 and let the x max be 80. So when I hit trace this time, I still see the function, but I'm probably zoomed out a little bit too far. So I need to come up with a better y value because I'm too far out. So my recommendation here is you can back up. I'm going to hit trace 10, enter. The function will go there, or the little bug or the little spider, somewhere around, well, it's a very small number. So I'm around 2. So if I hit trace 2, enter, the bug's in there, right on that corner, and that's kind of what I want to see. So hit your y equals, and I can see this a little bit better zooming in. But I've destroyed then, when I zoomed, I've destroyed my x, so I'll need to go back and set that to 80, 0 to 80. So here's a pretty good view of the function, and it's saying let's calculate at 30. So hit trace 30, enter, and I can see the first answer is 1,351 computers. I'll try 40. The second answer is 1,232. I'll try 50. And 1,293 computers. So it says graph the function between 0 and 80, and this is a pretty good picture. I think I can even do a better picture if I play around with my y part. If we change our y window between 0 and 4,000, we'll even get a better picture. And again, it's frustrating for students to know what to set the window, and my recommendation is just kind of play around with it. You're not going to hurt it. But eventually you'll see that if you go between 0 and 4,000, you have a pretty good representation here. I want to show you how to find the minimum. We could either use the find the minimum through the table setup. If you go to table setup and start at 0 and go by increments of 1, you could hunt around for the smallest y value. Following along on the x's, you can see that I'm going from 1,400 to 1,300, so it looks like I'm still kind of decreasing. 1,200, but now it's kind of going back up again. So now I'm back up in the 13. So somewhere around in these 40s was, in fact, somewhere around, I think around the 41, because I'm peaking right here at a solution. So it looks like the lowest part is somewhere around, if I let x be 41, I get the 1231.7. But that's not my recommendation. To find the minimum, my recommendation would be hit second trace. It's a calculate key. We're going to calculate the minimum, so I'm going to hit number 3. And I'm going to guess to the left, which I know 10 is to the left. That's my left bound. I knew that 40 was the minimum, so I'll guess 60 for a right bound, which I know is, so you'll see the left bound here, this arrow. The right guess is here, and then I think my guess, it's asking me to guess here, so I'll guess 40. And this is the actual answer. It's a little bit more precise than the table setup, so that would be my recommendation of your process. Guess left, guess right, guess on, to find the exact answer. You can see this is the same thing that you got when you had table setup. So remember, your y is your f of x, and you can determine if it's a function or not through the vertical line test. You can evaluate. This says if you let x be negative 50, what is the y value? So looking at x to be negative 50, it looks like the y value would be 10, 20, maybe 30. Okay, I hope that's helpful. Email me with your questions. Have a good day.